Hello, welcome back to Learn Physics. In today's topic, we are discussing with the motion chapter revision portion, which I was doing in the last week Sunday. The same way I am doing some more numericals, okay, to be familiarized with the numericals and how to approach. See, one or two questions if you are doing, anyway it will be difficult for you to attempt the new questions. So while we are doing this revision topic and more questions, it will be convenient for you. And one more thing, so this is how, okay, now I understood. Usually children will be, yeah, V equals U plus AT, like that children will leave like that. So more than that, you should, my opinion is, you should write down this question first, okay, because you know the theory now. Now you should write down that question and read the question. Try to solve it. If you are getting the answer correctly, you understood the concept. If you are not getting the answer properly, you should see how I am doing, and after that you can try it once more. Okay, and when I am doing, while you are watching the video, maybe you will feel you understood the thing, but close the textbook, pause the video, try to solve it. After that, again you check whether your answer is correct or not. Okay, so better you can write down all these questions and try to do. Okay, so here on a 120 kilometer track, a train travels the first 30 kilometer at a uniform speed of 30 kilometer per hour. Calculate the speed with which the train should move rest of the track so as to get an average 60 kilometer per hour for the entire trip. So here the total distance is given. Total distance is given as 120 kilometer. First 30 kilometer. So first x1 plus x2 if I am considering, that I can write it as first is 30 kilometer and next 90 kilometers. That is equal to 120. Okay, then this 30 kilometer the speed is, so first one V1, that is 30 kilometer per hour. We should find out this V2. Okay, so here average speed is given. Average speed equals total distance travelled divided by total time. Distance travelled divided by total time. Okay, here we know the total distance, isn't it? 30 plus 90 divided by total time. That one we don't know. So first we should find out the total time. Okay, so here time to cover 30 kilometer. How we can find out time to cover 30 kilometer? Because we know the speed. Speed equals distance travelled divided by time. So time will be equal to T1, that is equal to distance travelled divided by velocity, 30 kilometer per hour. So we are getting it as 1 hour. Next is time required to cover rest of the 90 kilometers. T2 will be equal to distance travelled divided by speed. Distance travelled we know 90. That distance speed only we should find out, right? So that one I am giving it as V. This much of hours. Now I can substitute in this formula, right? Average speed equals, so average speed is given as 60 kilometers. Total distance is 120 divided by total time as T1 plus 90 by V. Okay, so here we can write it as 120V divided by V plus 90. So this one I will write it as here 2. So V plus 90 equals 2V. So 2V minus V will be equal to 90. That is V equals 90 kilometer per hour. Okay, like that you will get. Understood here? You should use the formula total distance traveled divided by total time. And our whole segment we are dividing it into two parts. First 30 kilometers, next is 90 kilometers. That is the only difference. Clear on this? So the next question is, find the displacement of a body whose velocity time graph is shown below. So velocity time graph is given. We should find out the displacement. From velocity time graph, how we can find out the displacement? Velocity time graph, we can find out two things. We can find out acceleration and we can find out the displacement. Acceleration, how we can find out? By finding out the slope of the graph, we can find out the acceleration. Okay, so how we can find out the displacement? Area under the velocity time graph will give you displacement. Displacement equals area under the graph. Area under the graph. Okay, so how we can find out the area under the graph? We can divide this into triangle, a rectangle and a triangle. Okay, so here area of first OEB, triangle OEB plus area of rectangle EFCB plus area of triangle CFD. Okay, what is that area of triangle OEB? Half into length, half into base into height. So half BOE into BE plus EF into CB plus half base into height. FD into height is FC. So tell me, what is OE? 2. Here it is 2, right? So half into 2 into BE. What is that BE height? 10 plus EF 8 to 2. 8 minus 2 is 6 into CB. CB is EF into FC we should write, not CB. FC. So FC, what is FC? 10 plus half into FD. FD is 8 to 10, that is 2 into FC. FC is this height, that is 10. So you should add like this. Okay. So here you will get it as 10 and here you will get it as 60 plus 10. So it is 80. This is in meter per second and this is in meters, right? So the answer will be meter. Okay, this is how we will be finding out the displacement. And this kind of graph itself, if they are asking you to find out the displacement till 8 seconds or till 6 seconds, like that if they are giving, you should find out that portion, what will be the displacement. And suppose they are telling you to find out the acceleration between 0 to 2 seconds. So you can draw a graph, the slope here and find out y2 minus y1 divided by x2 minus x1. And what does this depicts? So velocity is constant. It is moving with the constant velocity, isn't it? So it is called a acceleration is 0. So here it is uniform acceleration. Acceleration is 0 and it is retarding. Velocity is decreasing with respect to time. So it is retardation. This comes under retardation. This comes under uniform acceleration. And this will be acceleration is 0 since velocity is a constant over there. Okay, clear? So next one is, starting from a stationary position, Anil pedals his bicycle to attain a velocity of 10 meter per second in 25 seconds. Then he applies brakes such that he again comes to rest after next 5 seconds. Calculate the acceleration of the bicycle in both cases. Also find total distance covered. So starting from a stationary position, that means initial velocity is 0. Anil paddles his bicycle to attain a velocity of 10 meter per second in 25 seconds. So initially velocity is 0. Final velocity is given as 10 meter per second for the time interval 25 seconds. Then he applies brake. So it is coming to rest position such that he again comes to rest. So velocity equals final velocity of the second part is 0. After comes to rest after next 5 seconds. There also time will be equal to 5 seconds. What is the initial velocity here? What is the final velocity at this position? That will be the initial velocity over here, isn't it? So after attaining for 25 seconds, then for next 5 seconds he is applying the brakes. Okay, so calculate the acceleration. Acceleration V equals U plus AT. So U is 0, therefore A is equal to V by T. So 10 by 25. So 2 by 5 meter per second square. So here in second case V equals U plus AT. So we need to find out A, that is minus 10 divided by 5, that is equal to minus 2 meter per second square. It is retardation. Find the total distance covered also we should find out, right? So here what is the distance covered? S is equal to ut plus half at square. U is equal to 0. So half at square we can write it as half into 2 by 5 into 25 square. So we will get it as 625 divided by 5. So 125 meters. Here we can find out S in that same way. S is equal to ut plus half at square. So U is, what is U? 10 into 5 plus half into minus 2 into t square. So here it is 50 minus 25. So you will get it as 25 meters. So what is the total distance covered? See, 125 minus 25. So you will get it as total distance covered, right? So total distance covered is 125 by plus 25, that is 150 meters. So the next question is, the velocity time graph of a body is shown below. State the kind of motion in OA and OB. This is OABC. Okay, OA and OB. Just now I discussed about that. That's why I thought that I will tell this question also. So OA, what is that? Velocity is increasing with respect to time. So what is the kind of motion over here in OA? OA is uniform acceleration. Velocity time graph is increasing with respect to time. Velocity is increasing with respect to time, and it is a constant. It is a straight line graph. Okay, with a slope. Then we can say it is under uniform acceleration. And OA and not OB, it is BC. So what is the BC? In OA it is uniform acceleration, and in BC it is uniform retardation. Okay, it is in retardation there. Velocity is decreasing with respect to time, isn't it? As time increases, velocity is decreasing, so it is uniform retardation. Next is, find the velocity after 10 seconds and after 40 seconds. What is the velocity after 10 seconds? After 10 seconds, the velocity is uniform. After 10 seconds, velocity is, what is the uniform velocity here? 20 meter per second. And after 40 seconds, what is the velocity? Velocity comes to 0. So velocity is 0 over there. Okay, then what is the negative acceleration? We should find out the negative acceleration. How we can find out the negative acceleration? In a velocity time graph, the negative acceleration can be found out with the help of finding the slope of the graph. So for that I am drawing a small triangle like this. So slope of the graph is slope of BC will give you the negative acceleration in velocity time graph. So that is equal to y2 minus y1 divided by x2 minus x1. So what is y2 here? Second position is this is x1, x2, y2, and this is x1, y1. So here this point how we can write 30, 20, and here this point we can write it as 40, 0. Isn't it? So y2 is 0 minus 20 divided by x2 is 40 minus 30. So we will get it as minus 20 divided by 10. So it is minus 2 meter per second square. Okay, clear? Then next is find the distance between 30th and 10th second. What is the distance covered between 30th and 10th second? So this area under this portion, area under, so this one, area under A, B, D, E, that portion. What is the area under that portion? It is a rectangle. Area of the rectangle is L into B. Length is 10 to 30. It is 20 into height is 20. 20 into 20. So we will get it as 400 meters. Okay. So this will be the distance between 30 and 40th seconds. Okay. Clear? So next is different displacement time graph is given here. You should tell which is the type of motion here. Displacement and time. It is a straight line with a slope. Then it is under uniform motion or uniform linear velocity. That also you can say. It is moving under constant velocity, uniform motion. See here what will happen. Displacement and time. It is under uniform motion. Then decreasing the distance with respect to time. Okay, displacement, that the time, as time increases, then it is coming back to the previous position. Okay, well, displacement is decreasing, so it is reaching to one particular point with a linear velocity or under uniform motion and coming back. Distance is decreasing, displacement is decreasing with respect to time, isn't it? So it is decreasing it is coming back to the previous position, okay, after some time. Okay, that also under uniform motion only. And here it is an irregular shape. Displacement time graph is an irregular shaped graph, means it will be under non-uniform motion. Okay, so it is under non-uniform motion. Uniform motion. Okay, clear? So this is how we can find out. So this is uniform motion only, but first increasing, then it is coming back. Okay, that is the graph. Okay, so clear for you? I think this is clear for you, and that's all for today. And if you like the channel, please don't forget to subscribe. Thank you for watching. Bye.